I would start a little bit for warming up, because one thing that I thought was really interesting in your talk, Julia, was to see that this interesting interaction between waves and currents that's not correlated. So that produces hot moments when a strong current hits a strong wave. I'm not sure if I saw a lot of hot spots in your model, but there were certainly areas which were more important. So how important are hot moments and hot spots for your modeling, and what do you think, which resolution do you need to capture them? Sorry.
I think it always depends on the application. Thinking about what we were talking about yesterday, where it's really depending what your question is that you're trying to answer, for sure. In some of my work, in terms of hot spots, some of the spots that I think about are the seabed water interface, where that even on millimeter to centimeter scales, you can get gradients in either the sediment texture or especially in the biogeochemistry in terms of oxygen gradients that disproportionately affect what's around it. And they affect, the horizontal sediment transport on scales of meters, kilometers, and so on. And so in terms of hot spots, that's one of the main hot spots that I think about. And then in terms of hot moments, I think, storms are a great hot moment, right? Not sure.
Thanks. Storms is a good keyword. Irma, you have modeled storms a lot. How do you think your model outputs for extreme weather could actually translate into regional forecasts or into coastal ecosystem information or social impact, societal impact information?
Yeah, I think we get a lot of lesson today for the integrated of the model, and the big problem of the forecasting the extreme events is basically in the accuracy of the model. The first is about the accurate and the sparse of the model. And this part of the data observation. So we need to improve the accuracy first. And to do that, we have a lot of strategies for improving the model forecasting, especially for storm search. So we need high resolution in spatial. We need couple model from air and sea interaction, capturing that. And for the, we also can integrate it with the other models, like ecosystem model and economic model. So we try to combine all the models and integrate it. And I think because we have to have the benefit or useful information for the societies. So we also can provide the useful information to community development program adaptation in the local people or in the coastal region. So we can enhance their capability to mitigate the forecasting. But it's very, I think, take many efforts to do all of this. But I think this session today can be give us perspective for take the multidiscipline and integrated all the model, so it can be tools in decision support system for the local government more useful. I think that's so.
Yeah, thank you. And Michael, from your perspective, which indicators are most critical for actually linking coastal dynamics to macroeconomic models or to adaptation planning?
Well, the first observation is that coasts don't exist in macroeconomic models. They just take the entire macroeconomy. I don't know, Colombia is just one big thing. But when you looked at the presentation from Yoon, for example, in order to shock a macroeconomic model, you can actually use the satellite information to see which settlements were shocked, which transportation routes and supply chains were affected. And this helps you then to create reasonable estimates on how to do these macroeconomic shock experiments. So that's all possible. And when you can also use so much mobile phone information, where you actually know more about the behavior of the people. And when it comes to adaptation, these things are really important. So that there's this example that there was, I think, an article in an American newspaper. What would have happened to the cyclone going into St. Louis if they were prepared as Bangladeshis were, because Bangladesh has a very good early warning system. People are prepared. And if the US would have been equally prepared, the damages would have been much, much lower. So this brings me back in a way to all of these economic variables you get from satellites and other means nowadays. It's actually, I think people call it warm data. It's kind of Bruno's types of, do you have just individualists sitting there who don't cooperate, and when a storm hits, they just get themselves out and the rest they don't care. So it's really more how are societies organized in these coastal areas in order to have a collective response that really brings then massively the shocks down. So I think that's the new frontier. It's the warm data that we will have to collect. And this is, there's only the one Michael around, I guess. He's the only one who collects this. So we need more of this.
It's a good point. It's a bit frightening for a natural scientist like me to collect smartphone data or something like that, but maybe it could be good. Yeah, thank you. So we would transition to the questions from the audience. I would go to the Mentimeter, and now I really understood why I should be sitting there, because I just have left and right arrows and now need up and down arrows, but I will just crouch there and try to make up for it. So yeah, and I will probably hand the questions first to all of you, and maybe if you want to respond, you just let me know. So what response options do you see to combine smart adaptation and mitigation in coastal regions? So combining smart adaptation and mitigation.
Right, those are mangroves. We have seen so many presentations exactly on this. Brings mitigation, adaptation together. It's very smart, and what's really interesting about these compared to gray infrastructure, a mangrove is way more knowledge intensive. You need to know so much about the mangrove itself and the system around it to design it well. So these are truly smart options in the sense they're higher technology, and you need higher technology than just to do a gray infrastructure. So this makes them smart again, although they are natural.
I agree. My first thought was mangroves and blue carbon systems in general.
Yeah, I'm agree at all about nature-based solution that talking in yesterday, I think. So combination between mangrove and then artificial of coral reef, right? So maybe but yeah, Indonesia actually try to protect the north coast of the Java by develop or build the giant wall-sea. And I don't know, maybe that's a policy from the decision of the policymaker. And I want to criticize that because the nature-based solution is more useful for protecting the coastal area, because we have issue of about the environmental. So it's leverage. This issue is very concern, our concern actually. So maybe you have you have a suggestion for scientists to become policymaker become understanding about this issue.
Yeah, there is one question in the Mentimeter which says, ideally models inform decision making. Who do we consider as decision makers? Who are we making models for? So I would take especially also that last question and give it to all of you, but then maybe also think about the first question, like who would be decision makers for you model, starting.
Yeah, I think we have limitation for inform directly to the government. So we need to bridging our knowledge of the scientific model by develop the tools, the powerful tools. I mean, and this must be business process of the scientific perspective, because we need to make the tools of the decision support system that's and proving by the very high accurate of the forecasting first, and then we can making open collaboration with the government in the authority, local government and operational national authority for the natural disaster example, and very open collaboration with try to make the tools powerful for using in the term of the making decision for all level of the policy decision maker. And I think the second one is we also try to make the decision makers is understand what kind of the knowledge of the climate change, and that's very difficult also to make sure they understand the worst of the tipping point of the climate change, and now we become 1.5 degrees Celsius and increasing very significantly. So I think this work is never stop to make the all people is educated about it. Yes.
I think of course it depends on the question. I think there will never run out of stakeholders and new questions. This makes me think of a phrase that I learned when I was a graduate student, which was one person's model is another person's parameter. And so, what my entire model is about might not even be a parameter. It might be a parameter of another model that goes into a parameter of another model that goes into some sort of, economic or socio-economic model. And so when we're thinking about decision makers, it's, there's the direct decision makers that I might think about, people who are, thinking about in the US, we have the Clean Water Act, and who are legislating or making policy about how much sediment, how much nitrogen, how much phosphorus can come out of different areas. And, it's the people making those decisions that might be, my sort of direct decision makers that I work with. But on the other hand, there's also the sort of indirect decision makers of, who are the scientists that are going to use my output that will also have their own decision makers as well. But I just, so I don't know if I have one answer.
Okay. I go back to Bruno, actually. many people nowadays again think that policy making is a tame problem. You know, it's you said the Volkswagen factory. You know, it's Trumpism. You know exactly what's right or wrong, and you go for it. And it's easy, and there are no complications. But all of those guys will find out that the world is wicked. And so for a wicked problem, we need to understand the world more and more from the bottom up. You know, what we discussed before, we have now citizen science and other things, satellites, where we have much more bottom-up information, where we can construct from the bottom up much better representation of decision-making individually, but then also in a social context. So sometimes people call this collective intelligence. I think we as scientists, we hold some kind of responsibility to construct these kind of models in order to keep democracy up and embracing diversity. Because if we do monolithic Volkswagen factory kind of policy tools, then in the end there will be a little bit of a self-fulfilling prophecy that the world will become more like that. So here our own curiosity-driven research needs to produce these more richer, the more wicked problem-solving tools, which to my mind, we are quite far away to actually build it. We're still in the Volkswagen factory. I love Volkswagen; it's a good car, but social systems are a little different.
Yeah, thank you. I think the wicked problem and our responsibility is probably a very good last word for this discussion, honestly, because we're looking at the time. Raimund has been talking for 15 minutes now. So I would, if there's nothing urgent to say, I would slowly thank a lot to the panelists and give the word to him.
Thanks a lot. Did you just suggest 15 minutes? Plus a 12-minute signal that has been shown around here. When I look around, I'm really positively impressed how many people are still here. And I'm pretty sure that is not due to you waiting for the farewell words from the scientific director, but because you thoroughly enjoyed being here. And that is really fantastic. We did say at the beginning, modelers are poets, you may remember. And what we learned throughout the last 3 days is that modelers are hardworking, and they listen to others, and they're curious, and they do lots of things, amazing things basically. So input, output has been mentioned here. But there are so many challenges, wicked problems that you just mentioned. There's a saying in the country I lived in for a long time. You're crossing the river when you come to the bridge, right? So that suggests, in a way, if there is a wicked problem, you're crossing this wicked problem when you come to the bridge. And one of the things we possibly all learned here is that we need to build bridges. Many more bridges, because there are many wicked problems. And that is one of the things that I found really intriguing here, that we challenged ourselves. Those people coming from Earth system models, they listen to the biogeochemistry, the ecosystem people, the socio-economic people, and all the other ways around. So this ability, the necessity, but also the willingness to build bridges, I felt it's here. And it's here individually, and it's here collectively, and that's what we are certainly looking forward to. So I do think that this is definitely perhaps the end of a symposium, but it's also the beginning of us continuing to build those bridges across the disciplines and bridges into something meaningful. There's a life on the other side of the river. Don't forget it. So that is a bit the next step is important thinking, that we do build those bridges not for the purpose of constructing, but for the purpose of connecting. And that's connecting across thoughts, but in particular, connecting across people. So I do encourage further collaboration. You're all invited to join the club. We have been invited already to see other countries. Thanks, Andres. So it's really good. So there will be a follow-up from our side. There will be more that can be shared. But really, I take the spirit of collaboration and building bridges here. Please take it home with you. Enjoy the last minutes. The sun is still shining. And have a good return. I don't want to end here without not just thanking you, but in particular also thanking the many people who helped us here. I look at, say, Heike, I look at Alexandra and Alexandra too, and there's Julian probably somewhere around, yes. So lots of others who have been named and unnamed, so please share me in clapping hands and thanking all of those who did the lifting in the background and throughout the conference. Thank you. And Gabriella.
Fantastic student. Thank you so much.
Absolutely, yes.